Niaje, today I will make you understand electricity in the simplest form possible. Don't worry about hard calculations, they're not here. And also, I'm not going to let theory back us down. So let's get things started. Number one, we all understand that electricity is a form of energy that maybe drives motors, light our bulbs, drive our cars, and so on and so forth. But we fail to understand sometimes how does it work. So today I'm here for you. Let me use a bulb for an example. If you want to light a bulb, we need electricity to flow through it or through it, whatever the case. So for electricity to flow to the bulb, we actually need something to transmit the electricity, and that's why we have wires. This is an example of a wire. Actually, this is not an example of a wire, this is a wire. And they are made of conductive materials on the inside and non-conductive materials on the outside. These conductive materials are what actually transmit the electricity. And this sheath here, the red part, is the non-conductive material, which is basically for protection.
So a wire carrying electricity is like a rod that facilitates the movement of a person.
So we now know how to transport electricity from the generator to the bulb, but still the bulb will not light. What we need to do is to transmit the electricity from the generator to the bulb, then from the bulb to the generator, and we will form something that like a loop. Actually, we'll form a loop, and this loop we call it a circuit. So that's the next thing about electricity. For it to work, we need to have a circuit, a closed loop, from the word circle. So where electricity goes to the bulb, then back to the generator. Now, if we form a circuit, it will comprise of many things, but the most basic ones are actually current, voltage, and resistance. And if you know how these three things relate, you might be able to go and operate, or you'll be able to play around with many electrical equipment. So we'll start with current now as our number one. And current actually Current is the amount of electricity that moves from one point to another, maybe from the generator to the bulb. So if I have a wire with electricity flowing, then the amount of electricity flowing from a point to a next point is actually the electricity. As simple as that. And if we go back to the road that I was talking about, a road with people or person walking, then current is actually I will relate current I will relate current with the number of people walking on that road. So current is the amount of electricity flowing in a wire, and if it were people, then the number of people walking on that road is what we'll call current. Then again we have voltage, and voltage is as simple as this. It is the electrical pressure. The pressure that drives the electricity in that wire is what we call voltage. Simple as that. Then let's go to the resistance, and the resistance is actually the opposition to flow of current. What opposes the current to move from that point A to that point B is what we call the resistance. Now, I've talked about resistance, current, and voltage. Let's recap a little bit. We say that current is actually the amount of electricity, voltage is the pressure of the electricity or the force of the electricity, then the resistance is the opposition that opposes the electricity to flow one point to the next. Now, if you can relate these three things, I told you, you can be able to work around with very many electrical equipment. And how to relate them is how to relate them is as simple as this. We have Ohm's law, and Ohm's law is actually V is equals to I R. Now, this electricity comes in two forms: AC and DC. DC is actually direct current. Current moves in one direction. If we had a battery and a bulb where we are using this battery to light the bulb, then the electricity from the battery will be maybe moving from the positive terminal to the bulb, then from the bulb to the negative terminal, and so on and so forth. But AC current, the source actually changes. The source changes terminals positions. I mean, let me say this way: if we had an AC source and we have a positive and negative, then the positive and negative will be switching alternatively, and this will cause some kind of vibration. That's when you get electrocuted, you will hear some vibration. That is what is caused by AC current, where current does not move in one direction. Actually, the current in AC does not move. It causes a force that moves. It vibrates and causes some kind of force to move. That's all.